Well, good evening, everybody. Hope you're having a good weekend. It's been pretty warm here in our part of Texas. We're kind of under a very unusual pattern here. And we got a big trough making its way through the Rocky Mountains, a ridge on the East Coast. And when we have that kind of pattern, we're kind of in between on the bad side of the systems. So trough west, ridge east is one of the least favorable patterns if you like good weather. And you can see it right here. There's the large-scale trough. There's the ridge. And if we use our standard jet stream placement, there's the technique where you lay down the jet stream, and we find it pretty much running right along that line. The trough is right here. The ridge is here. And based on this, we kind of expect the surface front to be something like this. Now, it is a little bit different. We've got kind of an unusual pattern here. But you can see Georgia in the south under this warm sector, and they have had some bad weather. You've probably heard about the tornado in Hattiesburg, Mississippi last night. Not to downplay the stuff in Georgia today. They got probably about a good 20 or 30 tornadoes there. This is the storm that hit Hattiesburg last night at about 3:40 in the morning. And you can see it's part of this large MCS moving through Mississippi. And we have these cells out ahead of it. And that's always an issue of concern when you have cells out ahead of a line. Now, there were quite a few of them here. There's a lot of cell competition going on, so not very well capped here. But we do have a couple of main cells. There's this one and then one further up to the northeast. So let me fix my chat window, make sure there's no problems here. Okay, and then I'll go ahead and show you this Hattiesburg storm in more detail. This storm went right through the middle of downtown and produced a lot of damage. I don't think there were fatalities with this one, but definitely some houses damaged with this storm. And you can see it looks kind of like an embedded vortex. There's Hattiesburg. Let me run that through one more time. Now, the one feature you can make out is this notch here. So this is some sort of, this would probably be about where the rain-free base is, or we would refer to this as the bear's cage. So if you were out having to chase this at 3 a.m., yeah, you would have a storm right there with no other chasers. Have a cell to yourself, really. But yeah, you'd be looking this way into the notch, and you might get a glimpse of something here. But if we drill down to the velocity data, you can see some definite rotation. In fact, it looks like it's a little further to the south than I had pictured. Okay, yeah, it's down in this cluster here. So yeah, you probably would have a decent shot of seeing that. Now let's check out some of the signatures here. The first thing we have to keep in mind is where's the radar? You can kind of follow the pixelation and you can kind of figure out that it's up north like that. So this red here, this is the outbound area, this is the inbound, and you can see it pretty much has perfect rotation, cyclonic rotation right there. So this is the couplet, and it's pretty wide at this point, about 2 to 3 miles, so that's in the mesocyclone range, but you can see some tighter rotation coming together right there. And I'm going to put the mark right there. We'll go back and look at the reflectivity, and you can see definitely embedded there, so a lot of rain wrapped into that. Give me just 1 second here. Okay, just wanted to grab a little throat spray there. There we go. So there's the vortex. And then the other thing we should look at is spectrum width. That could be an indicator of a debris cloud, but we don't see anything like a debris ball or anything like that. This is probably just a large distribution of particle sizes here, probably hail, rain, large drops, small drops, all that, and atomized rain, possibly. Then if we roll this forward, we'll go back to the storm relative velocity, and now we've got something that looks more like a tornado signature embedded in this larger scale thing. So how strong is that? Well, I can see about 43 out and 62 in. That's about a good 100 knots right there. So you can see Hattiesburg up here. So you've got a lot of lead time to get this worked out here. Okay, so usually when you're forecasting something like this and you've got something like GR level 2 or 3, use these place marker things. These are very handy. Let me show you the next frame and I'll show you why. Okay, you can see right there, that's where the vortex is, the tornado vortex. Let me confirm that. 37, 38 outbound, 41. Strongest is right here, the strongest in. 65 here, so the tornado is there. Now, there's a readout of azimuth and distance right down here. And this is what you want to make use of. This will give you the vector from that old dot to the current dot. And you can see it's 50 degrees right down here. So you can use that to kind of extrapolate the motion and kind of see what's in the where it's headed. And it shows south of Hattiesburg, and the storm did go through the south part of the town, and we can project that even further. And there it goes, going through South Hattiesburg. You can see the motion. Now it's about 55, and then after that, 53, so that gives you a pretty good baseline of who exactly, right down to the street level, is in the path. It's about 110 knots of shear there. You can see these Doppler radars, these things are really worth their weight in gold. You would have had a hard time trying to analyze this with the old WSR 74 radars and WSR 57s. I mean, try finding a tornado in just that data. Elsewhere around the country, let's take a look. Go to the temperatures. Things have been pretty warm. Here in Texas, the bugs are out. I don't know if you saw any on the lens of that camera, but we've got a lot of ladybugs flying around. 70s all the way up to the Mississippi River Valley. 80s in Texas. There's 84 in Austin, 83 San Antonio. And then we get 90s here in the Rio Grande Valley. But there's quite a difference in Mexico. There's actually some very interesting weather going on in that area. We'll check that out in a minute. But you can see much cooler out to the west. And I think normally these values here run about 80 this time of year, south of Arizona. So we'll hold that thought for a second and go to the satellite. You can see the next system coming on shore here in California, so they're getting hit one after the other. I guess that's good news for them. I don't know if there's any complaints about the rain there in California. I'd be curious to hear if people are getting sick of this, but yeah, there's the next system, and it looks like we do get a break here. Pacific looking a little bit clearer until we get this next storm, and that thing looks pretty busy there. So how do we analyze the jet stream on this? This is kind of a good skill. Usually in these baroclinic clouds, and let me show you, this is kind of the comet cloud here. We have this area of upper level cirrus kind of embedded in that. And then some of the stuff is a little bit lower. Usually the jets will be right on the boundary between that and the drier mid-level air out here. So we would place the jet stream something like that. And it's been a while since I've learned about occlusions. I'm kind of rusty on this. There's a type A and type B occlusion, and I believe this is probably a type B. The type A has this thing completely connected in as one system here. But anyway, that's just nomenclature there. There's the jet stream, and then to find the polar front, you just kind of refer back to your basics, and that's in some of my forecasting books. You can see some diagrams of this. Warm front. So we know California's got a warm front along the coast in the San Francisco area. Then north of that, we've probably got a occlusion. So that's what's happening, and that's what we're going to look for on the charts of California. I guess we can take a quick look at the soundings. I'm going to go back to this morning's sounding, and we'll look at what was going on in Georgia before all those storms developed there. I haven't had a chance to assemble all the charts, but let me see if I can show you SPC storm reports. They've got a list of what's been going on, and you can see here we had an outbreak start at about 3:20 and continue on through the 5 and 6 o'clock hours there. No, I'm sorry. I forgot they switched this over to Zulu time. This is 11 and 12, so this is actually earlier in the day. But there's the position. You can see pretty much there in central Georgia, a little bit there near southeastern Alabama. So what did the soundings look like for that? We'll pull up the Atlanta sounding there at Peachtree. Wind doesn't look too interesting, just kind of light and variable near the surface. They may be a little bit too far north, but there's some very good moisture there. Starting out with dew points there in the low 60s and actually pretty deep, all the way up to about 850 to 900 millibars. So you can construct a parcel, base this off the afternoon temperatures, and that paints out some pretty decent cape there, and there's some good mid-level dry air, which is important. And of course we have the all too important bulk shear. Got 120 knots there up at 39,000 feet. So that means when we get the anvil developing, that's going to blow that downstream. The precipitation core, even more important, that's also going to get advected downstream. And that'll keep the updrafts pretty much clear of being shut down. Do we have any other soundings in that area? Appears not. The Weather Service, in their infinite wisdom, they don't have very much sounding density there in Alabama, so I guess we can look at Tallahassee. I really wish we would fill in things with a few more soundings. We can do better. Soundings are not that expensive. Fairly decent moisture there. This is at Tallahassee. You can see the cape, or the lapse rate's not quite as steep, but we do have the dry air, and you can see the shear is a little bit better. All we need is a little bit of southeasterly winds at the surface, and that would give us some very strong curvature with these 35-knot winds at 3,000 feet. So all you need is a bit of backing, and you're pretty much set there. Let me pull up the thickness chart, and we'll just kind of work up the analysis. I like to base this off 18Z because by 0Z, the model output is stabilized a little bit, and that's pretty much good enough for what I'm trying to attempt here. So this will give us the current weather and kind of give us the dynamics, and this is what I was talking about in Old Mexico. Look at that thickness gradient there, very intense. So we've got the cold front, the bulk of the cold front rolling through the north part of Mexico right there, coming through Chihuahua, and I don't know all the other cities, I guess Durango, somewhere in here, but we would probably see some interesting METAR trends, and maybe I'll pull that up in a little bit. We'll see how that impacted Mexico. But that's where the cold front is. And we can kind of extrapolate that to find out where it is in Texas. Looks like maybe we have a bit of a warm front way down here. So we'll kind of look for that too. And maybe that connects up to this region right here. Then on the Pacific coast, we know that that warm front is in that region. And this works out pretty closely to what we had on that satellite picture. And of course the jet stream right in the back, and then over the baroclinic zone, then over San Francisco and the Sierra Nevadas. So there you go. That's the analysis picture. And we can take a look at a few surface plots. There's probably not a whole lot of need to go over this data, but this will show you what it looks like as the warm front approaches in California. And when you look at surface data, you can recognize this in this time of the year when you have 50s and winds out of the south and southeast. That would indicate probably a warm front on the way, that and the clouds. And then in Texas, we have our own changes going on here. You can see it looks like that cold front. Remember, I extended that out of Mexico. And that does kind of correspond to what we have here. Very strong winds in the Midland, Big Spring, and Lubbock area. In fact, Guadalupe Peak right there, gusting to 63. That's a good indicator of cold blast working in here. So we should see the wind starting to come up in central Texas tonight. Looks like maybe probably a little bit of that has even made it out east of there too. So maybe we have two waves coming through. Now further out in the southeast U.S., it looks like we do pick up some of that easterly component. And you remember how important that was on the sounding. Well, there it is. And if we have localized backing, that's even better. So probably a warm front like that, and we've probably had the storms along and just north of that boundary. And then Mexico, I wanted to show you that real quick. This is kind of an unusual pattern. Very strong winds here. I guess that's Monclova maybe. But very strong southwest winds and dew points 0 right there at Monterey. 5 at that station. That's very, very dry. So there's been a lot of adiabatic warming. And where would we place the cold front? Probably something like that. This could be dry line air here, especially with that 93-degree reading. In fact, we could very well have the cold front like that, and this could be dry line air here. That would work if we saw that in Texas. Certainly, I'm going to probably just assume that's dry line air right there, and then the main part of the front would be here. Okay, so there we go. There's our surface analysis, and yeah, we do got storms going on right now. We should look at that also. There's a lot to cover here, man. Let's go to the Weather Service page and kind of see where we need to start on this. And I'll pull up maybe one radar site, and Louisiana right there. One area, and also near Pensacola. So I'll pull up Louisiana and get that started. Let me make sure that data is loading. It's not. There we go. All right, and while that's coming, I'm going to take a look at the chat real quick and see what's going on right there. We've got almost breaking 30 viewers. That's excellent. Okay, let me just kind of scroll through this real quick. I see we have a lot of our regulars, Lexi and Michael, and Sue and Kevin, and Ron made it back. Alexi says 4 fatalities in Hattiesburg. That's too bad. Probably with that being 3:45 in the morning, a lot of people probably were not aware of what was happening. It's kind of scary. Sarah says it's warm in northern Indiana with 60 degrees. Very unusual. I remember how rare even 50 degrees was in Illinois this time of year. We would look down at Tulsa and Oklahoma City and see them up near 60, and that seemed like tropical paradise here. The Weather Channel said 4 dead in Hattiesburg, 50 injured, damages close to $250,000. And Okay, 60 in Peoria. All right. I think our radar data should be coming in, and this is current. This is right now, 8:20 p.m. Central. And we've got quite a few storms with tornado warnings. We can take a look at the warnings real quick and see which ones are radar indicated and which have been confirmed by spotters. Looks like all this right now is radar indicated. This one has been going on for a while. This is east of Alexandria, northeast of there. It's definitely got the supercell appearance. That's radar indicated also. Well, hopefully radar indicated rotation, and maybe that's a good sign we haven't had too much damage from these. But anyway, that's got definitely the a bit of the flying eagle shape there. These things here are more like clusters, and there's that tailwind storm right there. We can take a quick look at the storm relative velocity, and that kind of keys you in exactly where you need to be looking. This is not so much a meso as it is very strong TVS. So either this is going to be a wall cloud or a tornado on the ground. And we've got 35 out and 41 in. That's about 70 knots a shear. And you don't want to get too hung up on the exact values, because the distance from the radar can play a lot into that. You can see Shreveport's right there. This cell is about 40 nautical miles away from the radar. And as the bins get further and further away from the radar, you can see they get a lot larger and they cover a lot more area compared to the bins here. So you can't, that causes a lot of trouble when you're trying to compare one that's close to the radar from one that's far away. So when you get really far out, if you're actually picking up a TVS and not overshooting it, you might be mixing in some air that's not moving as much, and you would get weaker values at those distances. So basically, you can kind of use this to kind of keep track of trends and just get a general idea of the rotation. Here we've got 40 out and 35 in. That's about 70 knots of rotation, and I would definitely have a tornado warning out on this storm. And you remember that trick that I was showing you about forecasting movement? There's where the TVS forms. You put the marker on there, and then at the bottom you read out the azimuth. So we've got this TVS signature moving at 93 degrees relative to true north. So we would project it just south of Homer in about 20 or 15 or 20 minutes here. And of course, you can also use this kind of tracking to get an idea of the speed and project that forward and find out when it's going to hit an area you're interested in. Okay, so that's the radar presentation there. And I was taking a quick look at the chat. Felix says, thanks, Tim, your forecast's helpful. I watch the replays on YouTube if I missed a live cast. I appreciate that. EF3 tornado. I guess that's on the Hattiesburg storm. Okay, let's head into the forecast since we're 24 minutes in. And I still need to get dinner. Here we got the GFS, and let me get that started. Okay, so here you can see all the action in Mexico. And we can kind of use this to kind of differentiate whether we have a dry line or a cold front. So the cold front's right there, and I think Monterey was here. And these stations were kind of warm and very dry, so I think that does kind of suggest that we've got a dry line here in the main front there. Warm front is probably going to be down to the south a little bit, and then we would have an occluded front extending back up north. This is probably an area of frontogenesis, I would think, with this strong cyclonic, convergence against this kind of temperature field that will intensify the temperature contrast, so we're probably going to see that warm front there start to become a little bit more well-defined. So let's see, for tomorrow's webcast, you can see Texas getting a good shot of north and west wind here. Some of the cold air sweeping in from western Oklahoma into north Texas. This is by dawn. And then during the day, pretty much the same thing, and by the time we do the webcast, things a lot better in Texas, still a north wind. But it looks like another day of storms for Georgia. Let me add the fronts to this. They're a lot more well-defined. So, main baroclinic area here around the Columbia, South Carolina area, the main cold core there over Alabama. And you can see we've got this large warm sector. And we can kind of step this back and see where the warm sector is. This area here along the north and west periphery of the warm sector, that's the main severe weather risk, especially along the warm front there. So we're talking about probably the best areas for severe weather threat, probably going to be north of Mobile to about, I think that's Athens, Georgia. I keep thinking Marietta, I think that's up north. Athens, I think that's up here. Macon, I don't know, I'm messed up on my Georgia cities, but I know there's one here southeast of Atlanta, and that's what I would be concerned about right there. And if I would have to call a chase destination, I would say probably in here. So unfortunately, looks like the very same area is going to be under the gun tomorrow. For the webcast on Monday, fortunately that system moves on off, and we've got the occlusion working its way up the Appalachians. By the time we do the webcast, it's going to be looking like this. Occlusion over Virginia. A lot of the wraparound coming up into the Great Lakes area like that. So we're going to have some pretty good upslope and onshore flow coming into New England, and that'll mean a lot of snow and bad weather in the higher elevations. Out in the Great Plains, looks like we've got maybe a weak front setting up in Colorado. I don't know where that came from. Oh yeah, that's probably part of that system coming in from the Pacific. Let me back that up here. Sorry, Ron, we forgot all about California. Okay, there's the California system right there. Very strong onshore flow there. The warm front working its way in tonight. And then there's the cold front right there. And we can kind of track that moving into California tomorrow. So working into the LA area tomorrow evening, so that might be kind of interesting for the LA area. Looks like the warm front has kind of moved up to the Las Vegas area. And then it begins crossing the Rockies. So by Monday afternoon, we're seeing it coming into New Mexico here. Looks like a warm day for Texas, and probably we're going to see the dry line active. Maybe something like that. And then on Tuesday, looks like the cold front is working into Texas, and we've got the bulk of the cold air up north. Looks like the Great Basin is getting a very good chunk of polar air settling in across this region. So that's going to mark a big change in the weather for later next week. Rest of the cold air shifts southward on Wednesday, and for Wednesday, the cold front's going to be kind of like that. For Thursday, we see the cold front well to the south, but it's starting to creep up north here because we've got a little bit of a warm air advection pattern there. So pressure falls in this area, that's probably going to mean a little bit of a degrading of the weather pattern. Looks like the cold air manages to sink south through that area, so it looks like it doesn't really come together. Probably don't have much upper air support. But it looks like we've got some more cold air building in here around the 28th, pushes that southward. So it looks kind of like a cold pattern past next week. There's another outbreak coming south. I think the GFS did back off on that Big 10 60 millibar high coming south. This is the 30th, 31st, 1st, 2nd, and 3rd of February. However, the dominant pattern will be from north to south, so we're probably going to see things cool down quite a bit. We'll check the Canadian model. And still going for pretty much the same idea. I did compare the models, and towards the 31st, I think the European model had a little bit more warm air in this area, and the Canadian was a little bit colder there. See, there's the European model for the 28th. So let me compare this at the on the 31st to 12Z. And one thing I've showed you about the European model is very restricted, but this 850 millibar chart that they do release, we can use this. This is probably the best tool, I think, to compare the air masses. So you can see we get our pick of either the classic, which is just the sea level pressure and heights. That tells you a little bit, but the 850, that kind of outlines where the air masses are. So let's just do a very quick comparison. This is going to be for the 31st at 12Z. 5 Celsius line is going to run from Ohio to Minnesota to what looks like an Alberta Clipper over Winnipeg, and then back along the cold front, somewhat like that. So how does the Canadian model compare? We'll check it out, 31st 12Z, okay. Oh man, sorry, I don't have the 850 chart up. I'm going to pull that up real quick. Okay, 850 height and wind. Sorry, this is what happens when I've got too many windows open. Let's see, we're talking about 240-hour panel. Okay, sorry, I wanted the temperature. Okay, we're going to get there just a second here. And then we'll use this 850 millibar field to compare the European model with the Canadian model, and then we can jump over to the GFS and see what that's showing. Okay, so we're still waiting for the data to load. I might be able to get this to come in faster by just clicking on it. Yeah. Okay, we're good. Here we go. Sorry, guys. All right, so the 5 Celsius line is going to run like this. You can see it. The Canadian model is more pessimistic. The European model had the 5 Celsius line like that. And then we can kind of use the GFS to kind of see which one is in the best agreement. I'll bring that chart up real quick. There we go. And let's see what we got. We've got our 5 Celsius line like that. So that looks a little bit closer to the European solution. So the European like this. And then the Canadian model had it way out here. So I think probably the GFS is going to be the one to go with here. And just the general pattern we've got with that, I'll show you this real quick as my last chart. And I'm going to load all the charts so you can see the air masses coming in here around February 1st. I'll wait for that to load. I'll take a quick look at the chat. 32 people. Awesome. I appreciate y'all joining. It's going to be really fun when we start doing the supercells this spring. I'm going to jump in and do live casts whenever we got that going on. 510 decameters. Yeah, Fred is up in North Dakota and probably not liking that a bit. Okay, just as a reminder, we're showing the 850 millibar GFS. And we're looking at the GFS since this is probably the model to go with here. And also since I don't have the European data, you pretty much have to give the Europeans your firstborn before they give you access to the ECMWF. Okay, so we can look at this 850 millibar chart to kind of track the progression of the air masses. This is the 24th. Yeah, maybe I can use this to kind of squeeze the time and date in there. So you can use that to kind of track the date and time. And if you watch Canada up north, you can see the first outbreak spreading south around the 25th. And then the core of that hitting Fred there on the 27th. Then it looks like we get a little bit of a break, and then around the 29th or 30th, we have our next system coming southward. And this looks a bit colder. These purple values, those are minus 20 to minus 25. So 31st, 1st, 2nd, Alberta Clipper right there, breaking it up. And then there's another block of cold air coming south. And I would expect this to change when we look at this tomorrow. The main important thing is there's some hellaciously cold air to the north, 20s and minus 25 at 850. So we're going to be contending with this after the 1st. And exactly how far north or south it makes, we're just going to have to wait on the models and as we get closer to that particular date. So, wow, 34. It seems like I should just hang out here for an hour and watch the numbers build up. But I appreciate everybody tuning in here. I'm going to probably close it up here since I need to catch dinner, and I'm sure you all have things to do too. So, anyway, I'll just say goodbye, and I appreciate you watching. And if you have any suggestions or comments, let me know. And please like and comment and subscribe. Thanks, and we will see you tomorrow.